Now let's see how we connect two silicon control rectifiers in anti-parallel, that is back to back, to control AC power. The AC supply is here and the anti-parallel switch is here. We call it control switch, and this is connected in the lamp. This lamp is connected in series with this switch in this fashion, right? But we know that only when its gate, the silicon control rectifier gate, is triggered, then only this will conduct, this or this will conduct. So for that purpose we have taken two opto isolators, one opto isolator for each silicon control rectifier, and they are connected in this particular fashion. Now let's see how the power flow takes place. We know that for the silicon control rectifier, the current or the gate has to be triggered. That means current has to flow from the gate to the cathode. Then only this will fire. And we are going to achieve that not from the external triggering, but initiated by external triggering, but it triggers from its own supply. And let's see how it is handled. Now when this is supply, right? When this becomes say positive and this is negative, because every half cycle we know that this becomes positive and this becomes negative, and next half cycle this becomes positive and this becomes negative. So when this becomes positive, let's see how the power flows. The power will first flow here, reach here, and then this being reverse biased, no chance, it cannot flow. Then this here, it can flow here provided its gate is triggered, but gate is not yet triggered. So the power comes here, it goes this way, through the resistor, it comes here, reaches to the opto isolator, and the opto isolator, we know this is a triac inside the opto isolator. It can be a diac also, but this is a ZVS opto, so that is why there is a triac inside. So we know that only when the light falls on this is an LED, and this light falls on this, then only this is closed. Otherwise this is not closed. Now for let's assume that the light is falling on this. How it is falling, we'll see it later stage. So if the light is falling, that means how did it happen? The power started from here, reached here, this place, here, and then enters here. This switch is closed, comes here, and passes through this diode, goes here, and enters the gate, comes out of the cathode, goes this way, and through the lamp, conducting lamp, it goes this way, and reaches the negative. So once the current has started flowing between the gate and the cathode, the main SCR fires. How? Now the power flows this way, and this way, and this way. So the half cycle is completed. Now for the next half cycle, same principle follows. It will start from the, now for example, when this becomes positive, this goes this way, and this way. It can't go this way. It can't go this way also because it's not triggered. So it goes this way, and then enters here. And if the switch is closed, goes this way, and through the diode it enters the gate and escapes at the cathode and reaches this point. Only then the power will flow this way, and this way, and the main SCR, and this way reaches. So for positive half cycle and negative half cycle, the opto isolators trigger the SCRs, the corresponding SCRs, from their own anode supply, and that is how they are triggered and they work. Now let's see if we simulate this. What we have done for throwing the light, we know that the opto isolator has to throw some light on this for this switch to close. And what we have done here, these are nothing but LEDs which are at pin number 1 and 2, and this being the anode side and this being the cathode side. So I supply my logic from here and I connect both of them in series. That means if this goes high, the current will flow this way, and this way and to the ground. This is coming from my microcontroller or from any other logic circuit. So now let me simulate this. See, once I simulate this, we will see how now the AC supply is available. You can see this, and when I make this high, you see the lamp starts glowing. This lamp starts glowing. How? The process we have explained. This goes this way, 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 and both the LEDs are glowing and the light is falling on this. And when I make it 0, the lamp stops. So that is what is the process in which it works. Let us see once again. Now when I make it high, it glows. When I make it low, it stops. So that is how two silicon control rectifiers connected in back-to-back fashion would result in power delivery to the load. This is my load and this is my supply. The opto-isolator used here is a zero crossing type. That means the power will be switched on only at the zero cross, only at the zero cross of the AC supply. But if it is a situation where you have to control the power, such kind of opto-isolators should not be used. You should use a DIAC type opto-isolator, which is MOC3020 and MOC3021. This is MOC3061 and 63. These are ZVS type. These cannot be used for controlling the power, only for switching on at zero voltage situation. Whereas if you use MOC3020 and 3021, by giving delayed pulse here or by giving a control pulse here, we can control the power of the load also. We have explained these in separate videos. So that is how a silicon control rectifier used back to back can control power. This load can be a lamp, can be a transformer, can be a motor, but for any inductive load, make sure that we connect a number network across this. Number means there will be a resistor and a capacitor of 100 ohms and a 0.1 and a 100 ohms and a 0.1 microfarad in series across this to take care of the dV by dt requirement or the inductive load requirement for the circuit. The 0.1 capacitor has to be of 600 volts minimum, and that is 0.1 microfarad. 0.1 microfarad has to be 600 volt minimum, and the resistor could be 100 ohms 1 watt. Mind it, both of them are connected in series, and that is how the inductive load also can be handled.